Hi everyone, welcome to the third part of the tutorial on 2D flood modeling using HEC-RAS model. So by this time, if you already watched my previous two tutorials on this uh, series, so you already know we selected the watershed where we are gonna set up our model, and we already have processed a .dss file. So that's the HEC-12 boundary. You can see we are gonna set up the HEC-RAS 2D model for this boundary, but we are generating the input files for the HEC-8 boundaries, the entire region you see. Meanwhile, we already have our .dss file. I already demonstrated that in the previous tutorials if you didn't watch those. So you can go back and check. And today we're gonna uh, generate land use, land cover layers, and also we'll download terrain data and we'll process and we'll import it into HEC-RAS model. So let me just go back to the website. So we have to download land use, land cover data, and soil data. I'll give you all the links in the description below, and you can click on this and you can easily download. So we need to download this land use, land cover data for the year of 2021. If you just hit download, then it will start downloading and it will take a while to download. And I have downloaded here. You can see that's the download, and then I exported it, and you can see this is the like extracted one, and I imported this into GIS, and you can see that's basically covering the entire USA. And then I clipped it for the state of Texas. Yeah. Yeah, so it's for the Texas. You can see it's pretty big, but we need to process this data for this study area. So I just keep it for the state of Texas. That's good. And then yeah, we need to download the soil data set. Let me turn it off, and you can see all the land classes are there. And we need to download the soil database from this Dropbox link. I'll give you the link, and you can easily click, and you can just download the database. This is the latest one by state, and since we're in Texas, we'll download the data for the state of Texas. If you just click on this, or if you just click here and download, and it will just download as zip file the same way. This one, soil Sargo dataset for Texas. If you just unzip it, and yeah, you'll see one GDB file. So I'll use that later on. So this is how we can download soil data and land use and land cover data set. So now let's open HEC-RAS and try to create a new model. So I'm gonna use 6.4.1. So this is not the latest version. The latest version is 6.5, but I'm gonna use this one, 6.4.1. You can try 6.5, no problem. So first, go to File, create new project, and look at where do you want to save it. I'm gonna save it inside this folder, HEC-RAS 2D, and I have model files. Inside this hydraulics, I can just use the name. So what's the name of the watershed? You can use that name, East Eagle Creek. Yeah, let me give the name. So don't use any space in between. Yeah, so that's the name of the project. And if you hit OK, it's giving you the option that, okay, the by default, the unit system is US customary, and we are gonna use this one because we need to use this production system for the state of Texas and within USA, because we already use that production system. So let me check what we have in the model file. So inside that hydraulics, you can see we only have our project name and .prj. So that's basically the project file for HEC-RAS. We need to copy the projection file. So previously I saved it, and I'm just copying this one and then pasting inside this. And what I need to open RAS mapper. And here you can go to project. We need to set the projection system before processing anything. And you can just click, you can see it's there, click OK. So our projection system is done. It's in USV. So now what you can do, you can process terrain dataset. So right click on terrain, and if you need to download the terrain, you have the option. How can you do that? You can just import your shape file. Yeah, and probably let me zoom to the layer. It's here. If you just zoom out a little bit and show this view, if you click on terrain, and you can easily go to USGS, and you can click and you can just set the preview, means the current view, and then elevation model, and click query product. It will give you the option to download all the tiles. And if you just click on this 1 meter, so it's giving you the option to download. And if you just select these tiles, control this one, this tile, this one, and this one, and then if you just want to select those by using control, click this one, this one, this one, and if you see, if you have the data set, this will be green color. And yeah, and then you can add selected, that's okay. If you click start download, it will just download and see 2.78, and it will save inside terrain, and it will create another folder by the name of USGS, and it will just save everything there. So it will take a while, but I'm not gonna click on that. So this is how I downloaded previously, and I saved this data inside this folder. Let me show you that. Here I have everything there, the same data set I downloaded, and from there I need to process because I have different projection system. I imported everything into GIS. I used a Mosaic to new raster from data management tool, and then I basically have this one because I'm focusing on this study area. So I didn't even waste my space and time. I downloaded only to focus on this boundary. And from there, because this is in UTM coordinate system, we need to convert. Like if you want to check, you can check it's in UTM. So we need to convert it to a state plane. So first step is I converted the horizontal projection. I changed it to the same projection system we have, and you can see it's NAD 1983 state plane FIPS 4203, but you can see we have the same vertical values. That means we need to convert the vertical elevation to feet as well. These are in meter. So what we need to do, we need to use raster calculator, and then we need to convert this. So now if you just multiply each of the values by 3.287, so it will be something like this. So that's the final product I have, and I saved it inside my raster folder. So it's there inside the raster GIS. I have a folder called raster, and you can see I have all the raster and DEM feet. So that's the final product, more than 2 GB. So I imported this one here, and we need to use this to create the terrain. So let's go back to, so this is how we can download. I'm not gonna use it, close it, and then just right click, create new RAS terrain, and then you can go like 2D, GIS, raster, and DEM feet. So that's the final product. If you open, you can easily click on create, and it will start creating the triangulated network, irregular network team or train. So we'll have that as HDF file, and you can see it will be saved here within train folder. Maybe it will take a couple of minutes. It depends on the size of the watershed and also the resolution of the data set. So maybe it will take a couple of minutes for this kind of sub-basin, but for the HEC-8 we just saw in GIS, if you want to process everything, maybe it will take half an hour or more than that. So it's better to create the train for larger area. If you want to model this entire HEC-8, then you can share this with different modelers, or you can just model one by one. So you don't need to create the same train every time you want to create model for each of the HEC-12. So once it will be done, I'll create a land cover layer, I'll create a soil layer, and we'll combine land cover with soil to create the infiltration layer. And then based on the land use and land cover, we'll have a combination of soil and hydrologic soil group and land cover class. And then we'll assign our curve number. We have to select loss method. There are different loss method, like green and amped, or you can use SCS curve number. So in this case, we'll use SCS curve number because we're going to use frequency storm. We already prepared the data set. So once it's done, there are 4 different steps. So it's basically generating histogram right now, and then it will just add the layer at the end. Yeah, so it's merging together, and it'll give you the train, and we'll see the same train. We have it here. So it has like 1 meter cell by 1 meter. We're converting it to feet. So we have 3.28 feet by 3.28 feet. If you want to see, I can even make sure everything is okay. So that's the, like, in terms of meter. If you just convert this, it is 1 meter is equal to 0.3048 feet or 3.28 feet, the same. Yeah, still it's processing. Maybe it will take a couple of seconds. Yeah, and then we'll have it. So these are the steps. Once you're done with your inputs, we'll run the model. Yeah, still maybe it's completing some other processes. Sometimes it's time consuming, but you have to be very careful. Yeah, we have it. It can close. So what you can do, you can right click, you can change the properties. You can turn on this one, then it will update. Whenever you will zoom in, it will just change the color scheme, and you can see the differences. And if you want to see the difference between the high ground and low ground, you can just select 10. You can see the differences now. So basically it's applying the G factors, multiplying the values by 10, and you can see the differences. If you want to see the contour line, yeah, it will even open the contour at interval 5 feet or whatever value you assign, it will just show. So these are the options you have to basically investigate the data, but I'm not gonna use the contour. So this is the boundary we have. We'll use this boundary to create our model. So the next step, you can just save it first, and you can save the project as well. The next step is to create land use and land cover raster here. So right click on the map layer, create a new RAS layer, and then land cover layer. So if you click on this, and here from the GIS, I already created that. I clipped it from the conterminous USA to Texas. If you want to even clip it using your any county shape file or any other shape file, like a little bit larger than your study area, you can do that. So let me go back and click on the plus sign and find the land use and land cover. It should be inside GIS, and also inside raster. So that's for Texas. If you click open, it's giving you the option, and here you can see the land use, land cover classification. Like by default, it will give you the option, like the classes it has. If it has some missing data, it will be different. But yeah, based on this naming convention. So for none, I think you can, yeah, use this NLCD 2016, and then you will have it, even though we are using this data for 2021. So these are the classes we have. So let's replace this class as no data, okay? Because that's negative. So if you have no data, it will be no data, and there is no number now. So it is basically reclassifying the layer. And the cell size, it has 100 feet, but I'm gonna use the cell size as 10. If you want to make it a little bit even larger, or even if you want to make it a little bit smaller, so you can do that. You have the option to control it. If you just click on create, it will create that. Maybe it will take a while. So it is giving us some destination no data value has been climbed to 0, the original value being out of range. Yeah, that's okay. So I think we have it. See, that's the land use and land cover data set. See, if I turn off the terrain, it's basically giving you the same size as terrain. So you don't need to be worried about if you have even larger data set. So if you can download the data for the conterminous USA, and still you can import it, and it will automatically cleave based on your terrain. That's why I just remove the other areas, and I just keep it like a little bit larger than my model. If you turn off, that's that. So now it's time to do the same thing for soil. So go to create a new RAS layer, and this time soils layer. So now click on the plus and find the soil database, go back GIS, and you'll find this Sargo, Texas. Inside this, you won't find anything. Then you need to change it to all files. And at the end, you'll find that GDB probably. Let me see if it is there. Geo database, it should be here, or Sargo. There should be a geo database. Let me check. Otherwise, we need to download it again because that's the very important step we need to complete. If it is, basically we need this one, GDB, that link, and then it'll just, yeah, maybe we need to change it to all files. Let's find that. Yeah, slowly, yeah, it's there. Okay, just click open, it will automatically read, and it will give you the hydrologic soil group A, B, C, D, A/D, A/B, this kind of thing. Maybe you are familiar with that. Yeah, it's reading different tables, and it's matching with other tables and generating the hydrologic soil group. Once it's done, then it's basically reclassifying. It's loading the data, it's checking if there are some missing values. Of course, there will be some no data regions, so we have to take care of this. So later on, whenever we'll assign the data set, we'll consider no data for land use and no data for soil as well, and we have curve number for those. So in the next video, whenever we'll assign those values, and also the Manning's roughness, so we'll assign those values, but first create the layer and then we'll process. So these are the main inputs to the model, especially for 2D flood model in HEC-RAS. Since the unit is in feet, So you can see by default, it's also in 100 feet, but we'll change it to 10 because our land use and land cover dataset was also in 10 feet. Yeah, if you use high resolution, that means, yeah, for small creek, high resolution data is also good. Otherwise, maybe you are using 100 feet by 100 feet and your creek is only 20 feet wide, then it's very, very difficult to use a separate roughness value for the main channel. So it's always better to check the width of the channel, and based on that, try to refine the input resolution, and also will refine our mesh as well. Maybe it's taking a while, but it's reading and it's reprojecting the polygons because we have different projection system there, and we're reading the database, not the shapefile. So it's kind of projecting everything based on the projection system we used. And then it will show you a list here, whatever data we have. And then we have the option to modify the classes. Because in hydrologic soil group, if you have both A and B, so it will give you A/B. But HEC-RAS can't even read that A/B or A/D. We need to take care of those slash like oblique classes. So that's the reason we need to pre-process all this data set, and then you can run the model. Let me turn it off. This is our study area. I don't need to even show you the HEC-8 boundary anymore. Yeah, I'm turning it off, and every time I'll show from now on, I'll just zoom into my boundary here. And you can see the area. Well, let me check the area of the study area. So what we have in square mile or kilometer, we can even calculate that is basically a square feet. So let me calculate that. How can you calculate? Go to calculate geometry, area, and then the property is going to be area, and then here we can select the unit. So the unit should be square mile. That's what I like. US acre, you can use that as well, or you can use square mile here, US survey miles, and then the coordinate system, I think we already have it in the favorite. And based on that, if you hit OK, it's going to give you the area in terms of square miles. So it's almost 36 square miles. It's not even small, it's pretty big. So that's enough. Let me see if it is still, yeah, maybe it's almost done. We have to wait for maybe a couple of seconds or a minute. Let's wait because you have to be very, very careful while processing all this data set. So these are very, very important. Once you have this data, so that's why it's better to create these data set for larger area, for example, for HEC-8, and you don't need to process every time you are gonna set up the model for small HEC-12 regions or boundaries. So it's always recommended to generate the rainfall data for larger boundaries than for soil and land use as well. And later on, you don't need to just click there and now generate new raster. You just click there and add from existing terrain, and you can just directly import it. That's okay. Yeah, so the next step is we'll even create our plan, because we already have our DSS file, and from this DSS file we can definitely create our Unsteady flow data, because we have data for 1 day, but we distributed that rainfall into 6 minutes. So now the rainfall is not even constant. it's changing with time. So it's not steady flow anymore. It's unsteady flow. So we have to use this unsteady flow data and process. Yeah, let's show you this. If it is still processing, yeah, it's still processing because this data is for Texas, the entire Texas. So it's loading the entire data set, and then it will just clip based on our terrain data set and study area as well. So if you want to use unsteady flow data, go there, and what we need, just go to File, save unsteady flow data as, you can just use the name, what we use, the source, NOAA data, like NOAA Atlas 14. You can use like small letter NOAA gridded precipitation. Okay, NOAA gridded precip, because we're gonna use different plans. So here you can unsteady flow data, you can use like one PCT, means 100-year written period, and then you can just save it. So here you have the option like meteorological data. Later on, we'll use different boundary conditions, upstream flow, downstream condition will be a normal depth. So we have the rainfall data. So click on the meteorological data, and here precipitation or evapotranspiration is now disabled by default. So you need to enable that, and then you can see the options here. We are not going to use any wind. So precipitation now it's none. You have to use, like you have to select if it is point data, if it is gridded, if it is constant. If you want to use constant data everywhere within your study area, you can just use constant. If you have different points, means if you have different gauges, so it will automatically interpolate in between gauges. We're using gridded, so select gridded. And now we have the option to use that DSS file. So from there, let me copy that DSS file because we already created. It's in hydrology models. You have this data within hydrology 2D BLE. I'm just copying this and pasting it inside hydraulics model. This is the model. Yeah, so that we can easily get access to this data set every time. We'll copy the folder. So let me open. And if you want to use any factor, because we're not going to use any canopy loss, any surface storage losses, like, so that's why we need to use ARF, aerial like reduction factor. So it depends on different region. There is a way to calculate, but for this project, we're not going to use it. It could be either 0.91 or it could be different based on the area of the study, based on the area of the subbasins or the study area. So for the time being, it's optional. Just keep it as it is. We'll use that while calibrating the model if necessary. Otherwise, it's okay. We don't need to use any interpolation. So we already have it. If you want, you can use bilinear, nearest neighbor, because we already have our 6-minute interval data set. That's okay. So click on that, and if you copy and paste inside this model, then you can easily get access to that. Open, and here, since the plan is selected, the data, it's 1% means 100 year. So here you have the option to select like 1%. You can select only 1%, like one PCT, where you have one PCT. You can just select on one and then click OK. It will just automatically select everything whenever the model will run. We are not going to use any evapotranspiration. We're not going to use any pressure by this. Pressure is constant, like 10135 Newton per meter square. That's the atmospheric pressure. If you just click apply, it applied, and then you can just save unsteady flow data one more time. It's saved. You can close it, and later on, the boundary conditions will add. Whenever we'll add the boundary, we can see it. If we have, because now it's 2-dimensional model, so we have to use inflow boundary, we have to use outflow boundary, and we have to use overflow boundary. We'll do that. But for the time being, it's okay. Save the model. Maybe let me see if it is still opening. Yeah, because it's for Texas. It's just reading the entire geodatabase and loading the soil classes. Maybe it will take a while. So meanwhile, I can explain that, okay, we didn't even create any geometry. We'll create the geometry file. And then from there, we'll use our boundary, this boundary as parameter to generate our two-dimensional mesh. And we'll download like a roadway. We have our NHD plus flow line. We'll use this to refine the mesh. Yeah, we'll check whenever we'll be done with this processing. So in the next tutorial, we'll see that. So I'll try to make the tutorial like within half an hour or even a little bit more or less, so that you can easily practice and you can follow whatever I'm gonna do it here. But to generate the inputs and outputs, you need to spend a lot of time. And while doing this processing, maybe you'll see different errors. Sometimes you'll be able to resolve it by yourself. Sometimes you may not. Then you can just, yeah, put your comments in the comment box, and whenever I'll get time, I'll get back to you. Okay, so let's just wait. I'm gonna pause it unless it's done, and then I'll come back and we'll see. Yeah, so it's still basically doing the same processing. It's loading and reprojecting the soil database because it's the Texas. It's a pretty big area, and then it's maybe taking time. So I'm going to stop my video here, and I'll just let you know in the next video how it is going to look like. So whenever it will just load, I'll just do the same thing as I did for land use and land cover, but I'll just make sure that it's going to look like this. If you go to the HEC-RAS 2D manual, it will just load something like this. And if there is any missing data, so we'll just use no data as before, and I'll change the cell size to 10 feet, similar to land use data, and then I'll just create, and it will create one, and then I'll show you the next step, how to create infiltration layer in the next video. So thank you so much.